This is Britt Caswell with another example video. In this video, I'm covering example 1 from lesson 2-3 in the SavvasRealize Algebra 1 textbook. In this example, I'm going to be looking at the standard form of a linear equation. You might be wondering what that standard form looks like. It is an equation written in the form of ax plus by equals c. Alright, where c is just a constant term, some kind of number. So this is some kind of number times x plus or minus some kind of number times y equals a constant. So the standard form is really useful when we are attempting to budget things. So usually problems that you see with this will have some kind of maximum value that you can spend, and then you'll have cost per unit on a couple of things. So the example we're dealing with is looking at music festival tickets for a reserved seat and general admission, and then some kind of budget that this person has. And so the equation will help us to figure out how many of each ticket we could purchase. So when we go to write this out, okay, the reserved ticket seats, I'm going to call those X. And the general admission tickets are going to be Y. So if I go to create this equation, I would say that 25 times the number of reserved ticket seats plus 10 times the number of general admission tickets has to equal 150. So when we are dealing with standard form, creating the equation is very kind of natural, I feel. We can understand where the numbers are coming from and how they apply. So part B here, it says the explanation of the ticket cost, and then it says, what information does the standard form give you that the slope-intercept form does not? Well, the standard form tells you a couple things. It tells you the cost per unit in this case, although I would say kind of the amount per each x value and the amount per each y value, but I'll keep with cost per unit on this. This also tells you a final budget or some kind of maximum value, which is not seen in the slope-intercept form. So what they did was, in the book, they took this equation that we created and they converted it to slope-intercept form. Okay, I'm going to show you how they get this equation here up at part A. So if I want to get it into slope-intercept form, okay, I'm going to subtract the 25x over to the other side of the equal sign because we need to get y alone. So I'd have 10y equals negative 25x plus 150, and then I'd divide everything by 10. So y equals negative 2.5x plus 15. Okay, so this is all, again, converting to slope-intercept form. Which is not part of A, but it makes you understand where this equation is coming from. And so it says, is it easier to find the x-intercept of the graph of the equation using slope-intercept form or standard form? Well, remember the x-intercept is when the y value equals 0. So for the slope-intercept form, I would have to set y equal to 0 here, and then go about solving for x, right? So I'd subtract 15 from each side, So I'd get negative 15 equals negative 2.5x, and then I'd divide both sides by negative 2.5 to isolate x. Then I take out my calculator because I don't know that off the top of my head. So 15 divided by 2.5, that's 6. So here that gets me the x-intercept is 6. Now watch it with the standard form. Okay, so the standard form, again, I'm replacing the y with 0. So I get 25x plus 10 times 0 equals 150. Well, anything times 0 is 0, so that term falls out, leaving me with 25x equals 150. And then I just divide by 25 and get x equals 6 that way. So do you see how if it's in standard form, it's one step shorter? A lot of students get to where they can actually find the x and y intercepts just using mental math if it's written in the standard form. Okay, so that's the explanation I'm gonna leave you with. But there we are. That is our introduction to standard form. Until next time.